is different than watching me do it, right? Because when I come up here, hopefully, I'm not going to make any mistakes. And that's the downside of it, is that I'm not going to get lost the way you will get lost, right? So when you watch me, I'm not ever going to go down that wrong exit and get into some bad neighborhood in mathematics where I never get back, right? And that's the biggest problem when it comes to math, and that's what makes people hate it, is they don't have that confidence to keep going down the road in the correct direction. So try, and you'll be rewarded for that. But if you don't try, I won't have much sympathy at all for you. So when I come in and I say, I want to see your homework, you can't tell me, well, I worked. Right after class, I worked, and I didn't have time for the homework. Because my response to that will be, what do you think? I don't care. No. What do you think? Come on, you're me, and you're asking your student to do their homework, and you come in the next day and they haven't done it, and they give you the excuse that they had to work or something like that. What do you think?
Did you work all night?
Did you work all night? Okay. Why are you here then? If you have to work and you know you don't have the time to put in for the class, then you should not be in the class. There's a difference between enrolling in a course and actually doing a course. So just showing up here for 2 hours, 4 times a week, is not enough in this course. You must be able to go home and do your homework, especially because we're coming back the next day. So the stuff we do today, you will have had an opportunity to master in some sense and to raise any of those questions in yourself and bring them to me next class. So I'll start class next time. I'll be like, any questions over the homework? Dead silence means everyone's perfect or shy or a lot of people didn't do it. Yeah? I feel like I'm babysitting here. Sorry if I come across that way, but I think it's important for you to know that I do care about your success, but I don't have tolerance for no effort. All right, so let's begin. The way I think I'm going to do this, because this should be somewhat review, is I'm going to start working through some of these problems. Then I'll give you an opportunity to do some of yourself. And I'd like to get some dialogue going because I want to know where people are. And if I keep on turning around, no one's responding, I'm going to just start calling on people, and then you don't want that, right? But if you're like that one person that answers everything, you know that person in the class that you're just like looking out of the corner of your eye, you're like, okay, please understand that as a person who would know everything, that you should probably let other people have an opportunity to gain that confidence that you have, all right? So I hate to tell people that's enough, but I will say, how about, next one or something like that. All right, so let's look at number one. What I'm going to try and do is try and see if I can squeeze out of you mistakes, things that people do that are common errors. So let's do this first one. And I'm just going to write it down the way it appears. Here we go. First thing, what are they asking you to do? What are you being asked to do? Perform the operation indicated below, right? All right, so is this an expression or is this an equation? What's the difference? An equation must contain an equal sign in it, right? I don't see an equal sign, right? So this is not an equation, this is an expression. And so what we want to do is perform this operation on this expression. So we're going to take this expression and turn it into something else. That's all we're going to do. The operation they want us to do is indicated by that dot right there, which is multiplication. That's implied multiplication, right? So how do we multiply these two things that we call fractions? How do you multiply fractions? Do what? Cross multiply. Straight across multiply. Anything else? Reduce. All right. So let's take kind of a vote. How many of you have heard cross multiply before? Like you've heard it, cross multiply, right? When you cross multiply, what do you need to have in order to do cross multiply? You have to have an equation. Cross multiplication comes in play when you have an equation. All right? So we can't do cross multiply here because you don't have the equation. Now I heard straight across also. How many of you have heard multiply fraction straight across? Yeah? How many of you have heard reduce a fraction? I'm just looking for like language here. Yes? All right. Straight across and reducing are both valid. We could do either one here. So it's kind of like if you're going to go from here to Austin, there's a couple of different ways you go, right? You go 35. There's a way to get there 281 also, right? So we want to get to an answer, and there's multiple paths to get to the answer. The good thing about math is that as long as you don't break any rules, you should get to the answer. Some paths are longer than others. Some get you right there right away. So I'm going to do this one two different ways. I'm going to reduce it, all right? First, I'm going to do that one, and then we'll do it with just the straight across multiplication. And just look at the differences. We'll get the same answer. We'll see if one was better than the other. All right, so reducing. What did you mean by reduce? Go ahead and tell me what you would do here. I'm looking at you, but anyone.
I would reduce the 4 into 16.
The 4 into 16.
Instead of 1 into 4.
Okay, so you would turn this into a 1 and this into a 4. So what you're doing here is you're using the fact that because it's multiplication, you were allowed to do this, yes? You're allowed to say, okay, do any numbers go into 4 and into 16? 4 goes into both of those, right? Now, could we do the same on the 3 and the 9? Yes. So if we wanted to be a little bit more technical about this, I'm just writing this down, okay? This separation of multiplication doesn't have to be there. You could write this as one fraction with multiplying on top and multiplying on bottom, right? And then you can do this. I know you're going to sit there and look at, some of you are going to look at this like, why is he doing all of that? Like, I already have the answer. Got it. Okay, fine. If you're there, that's okay. I don't need to see all the work for it, but I'm just trying to get us to see different versions of the same exact expression. This is the same as this, right? Multiplication straight across. This is the same as this, because all I've done is I've switched the order of these two. That's called commuting. You can commute when it comes to multiplication. You're allowed to do that. And if I look at it this way, I could, if I want, split it back apart. I mean, I could, right? And then these two fractions can be reduced because they each have a common factor. So I know this is not what all of you would write down if you were asked to do this problem. I'm just trying to get us to see some of the things that we can do with fractions. So I'm just going to write down now common factor. 4 goes into 4 one time, right? 4 goes into 16 4 times. So I could rewrite this as 1 over 4, correct? And then times still, and then here, what number goes into both? 3. So 3 goes into 3 one time, and 3 goes into 9 3 times, and you get 1/3. Now that they're reduced, let's just multiply straight across. 1 times 1 is 1. 4 times 3 is 12. 1/12? We happy with that? Now, that was me just like playing around. Some of you would have just done this. 1, 4, 1, 3, right? And just go straight across 1, 12, and you're done. And that's fine, all right? Now, what if we did not do this reducing and we just did the multiplication straight across instead? So this would have been another option, 3 over 16. So you just multiply straight across. 4 times 3 would give you 12. And 9 times 16. 144? Now, even though that is correct, it's not reduced, meaning you don't have it in its most simple form. So you have to find a number that goes into both of these. So you could try like 2, and then you keep going, and eventually you get it down to turn into this. Or you just recognize that 12 goes into 12 once, and 12 goes into 144 12 times. You get 1/12 again. Okay, we happy about that? This all right? Maybe I shouldn't use the word happy. Are you content with that? What's the difference between that and number 2? Division. Oh yeah, that symbol there, that division symbol. That's like the old school division symbol, isn't it? Isn't that the old school? I mean, we learned that very early, right? When we're learning arithmetic in grade school. That's like the first division sign we ever see. Have y'all ever noticed what that division sign really represents? Like what that symbol is? Like if I write 7/8, right? That's division, isn't it? But I could write anything over anything, right? I could write like anything I want, question mark over question mark. That would be a fraction, right? Or I could just say like dot over something, like that over something. Anything over itself, right? So that's what a division symbol is. It's just a fraction, but top and bottom are represented by dots. So we're going to do this fraction divided by this fraction. So what's the rule here? Straight across? You have to flip it, right? Flip what? The second fraction has to get flipped. Okay, so that's the rule when it comes to division, is that you will convert it from division to multiplication. This becomes 9/2, right? This switches, right, to multiplication, but this guy right here flips. What's another name for a fraction that you've flipped over? Like 2/9, this 9/2 is called its what? Reciprocal. All right, so you're going to multiply, you can change division to multiplication, you're going to multiply by the reciprocal of this fraction. And now you're back to multiplication, you can go straight across. How about reducing? Can we do any reducing here like we did it before? Can you think of any numbers that go into 7 and 8 other than 1? No? Any numbers that go into both 9 and 2 other than 1? Any numbers that go into 7 and 2? No. Any numbers that go into 9 or 8? No. So this is it. This is as clean as it's going to get. Straight across we get 63/16. Now does this reduce? Does that reduce? I mean, I could turn it into a decimal. I understand I could do that. But is there a number that goes in both of these? No. And here's why. If there was, it would have happened here too. And since these didn't reduce, this won't either. So there won't be a common factor of both of those. All right, let me ask you this one. This one's not on the sheet. But what about this? How about 3/4 divided by 2? Okay, so you're going to recognize that 2 is actually a fraction. That way you can do the reciprocal. So the only thing I'm doing here is just rewriting 2 as 2/1. And now I'm going to convert it from division to multiplication. And that'll become what over here? 1/2. And does anything reduce out here? Any numbers that go into both of these or those or those? No? Straight across, 3 times 1 is 3, 4 times 2 is 8, 3/8. Is that okay? Sure you don't have any questions? If I'm killing you with how easy this is, I'm sorry. This is where I have to start. Okay. All right, so let me try and push this a little bit further. What if I wrote that down? Let's have some votes here on what this means. How many of you think that this means this? Show of hands. Okay. That means everyone else thinks it's something else? What else could that be? If it's not this, what else could it be? It could be 3 divided by 4 over 2. Do y'all see, does everyone see both of these seem almost like you could say either one? Yeah? So which one is it? You just get a coin out, flip it, heads or tails, right? No. This is bad notation. The way I wrote this on the board is incorrect. I have to be a better mathematician if I'm going to write something like that down. What I need to do is make one of these bars bigger than the other. If I don't, there's a problem in my presentation of the problem. So let me show you how I get this one. Okay? To get that one, I make the division bar here bigger. All right? So what this means is that you got to do all this by itself, then divide that by this. So all of the 3/4 by itself, then divide that by the 2. Do you all see that there? This one, I would write 3 big division bar 4 over 2. See, the smaller division bar is on this one. Okay. Why don't you try 3 and 4? They're up there. See if you can do 3 and 4. You should make some friends in the class, you know. You're going to be here for 5 weeks, almost every day. When you get 3, raise your hand just real quick, and okay, and then move on. If you need help, raise your hand or something. I can come assist you. All right, what you got?
Since nothing goes into each other.
If you can think of a number that goes into both of these, then you would reduce or these. So let's just think about, is there any number that you can think of that goes into both of those? Okay, so like 2 doesn't go into both of them because they're not even.
Mm-hmm.
3, only 7 goes into that, right?
Mm.
I don't think 3 goes in there, so, or does it?
8.
8, right?
Mm.
So you could do 3 into both of those. You could try, those are both even, right?
Mm.
So try 2 into both of those. And so you'll rewrite this fraction and that fraction next to each other again. Would you like me to put the answers up, just so you can see if you're getting them? Yeah. Now I'm trusting this answer key is correct. I'm going off of what was provided to me, but I will double check them because I don't trust it. How many of you got 1/2 for 3? Okay, that makes me feel good. Anyone get 4/21 for 4? Okay, good. All right. In terms of timing, I think where we are right now is about how much time it should take you to do those 2 problems, give or take a minute or so. All right. If you're still working on 3 or you're still struggling on 4, then we need to identify right now that we got to get you to the place where you can finish that in a quicker time. That means there's some deficiencies, some holes that we need to get filled. All right. But I have to leave that to you as a student to reach out for that help. Another thing you don't want is when you see a problem like this to go grab your calculator, okay? If you grab your calculator to do this problem, that means that calculator has become a crutch. Now, if it's just a blanket you have to hold in your arms while you're doing the work, that's one thing. But if you're actually looking to the calculator to do the math for you, that's something that's going to haunt you throughout this class, right? We need to have a basic number sense, basic multiplication, division number sense. All right, I'll work through these pretty swiftly here. 3 was 21/24 times 16/28. Still have this one. Okay, anyone want to volunteer how they did it? Because there's a couple of ways you could do this. Anyone want to say what they reduced or canceled? Or not all at one time, please. Don't speak over each other like that. Okay, what do you got?
So I reduced the 21 and the 28 by 7.
So you recognize that 7 went into both of those. So you went ahead and knocked that out first. 7 went into here, 3 and 7 went into here.
And then the other way,
4.
I had actually done 8.
You did 8 into both of those.
Yeah.
Okay, so 8 goes into here twice and goes into here 3 times. Yes, that will work. Now you could have done 3 goes into both of these and 2 goes into both of those, or you could maybe go further. There's, again, different paths, same answer. Then you multiplied across
3 and 2 is 6.
6, and then
3 and 4 is 12.
12, and then you looked at that one and realized that that can go down further. 6 went to each of these. 6 goes in here once, 6 goes in here twice. That's one way. I won't do another way, but if you had a different way of doing it, you hopefully got it down to 1/2 also. Okay, the other one, 4/9. And I'm going to multiply and flip it, so reciprocal, 18/42. Now, if you don't flip it, right, you are not allowed to do that cancel, the reducing that we're doing here. You're not allowed to do that until you have flipped it and turned it to multiplication. If you do the canceling out before that, it's going to be wrong. So at this point, you can do some reducing. So what I see, just right off, I see 9 and 18, right? That's what I'm seeing. And then I'm thinking, does 4 go into 42? Does 4 go into 42? No, but 2 goes into both of those, right? Because they're both even numbers. So 2 goes into 4 twice, and 2 goes into this 21 times. And now I'll go straight across. 2 times 2 gives me 4, and 1 times 21 is 21. And that does not reduce any further. Right? Can't go in, nothing goes in both those. All right. Let's look at number 6. Number 6, they throw something kind of different at us. they have 1, and then they write a 4 over 9, and then they put a division symbol, and then they put 2, and then they put a 1 and a 4 like this. This right here is kind of different than what we were looking at before, right? I mean, it's got a special name for it. That one too, right? Anyone know what we call those? Mixed numbers. We call those mixed numbers. And you're going to see them used throughout the term here, all right? I am not a big fan of mixed numbers, okay? And the biggest reason I'm not a big fan of mixed numbers is because a lot of students don't have any clue as to what they really are. Let me try and illustrate what I'm saying. 1 4/9. That's the way you'd say that, 1 4/9. A lot of people understand that what that would mean is like if we're looking at this as like chocolate bars, this would mean you have 1 chocolate bar, right? And additionally, 4/9 of another chocolate bar. That's what that means. But mathematically, that's the same as writing this, right? It's 1 plus 4/9. So why we write it this way is out of convenience, all right? It's just convenience, but students don't realize that that's an addition symbol between them. That's all it means. And later on, if you were to take more math classes, like if you were in Math 14, we would tell you just never to use mixed numbers ever again, all right? So unfortunately, we'll have to keep them with us this whole time. But there is a way to convert this mixed number into what we call an improper fraction. Anyone remember how to do that? There's like this little trick to it, right? Yeah, you do this number times this number, 9, and then add that number. What the hell? 1 over the, okay, so I'm supposed to go 1 times 9 and get 9, and then I'm supposed to do what? Add 4 to that. Okay, then what? Keep the 9 on the bottom, like do this, like this, right? How many of you remember seeing something crazy like that before? And so this is really what, 13 over 9? Y'all seen that? That's a look of, yeah?
Wouldn't
Yep.
it be easier if we turned the 1 into a 9?
Yeah, that's exactly. That's exactly what happens here, okay? Look, this little trick of 1 times 9 and then add the 4 and do it. What's actually happening is that you're taking this fraction right here and you're rewriting 1 as 9 over 9. And the reason you're doing 9 over 9 is so that you can have the same denominator. And then when you add these two together, you add the numerators up and you get this. Now, we haven't done addition yet. That's the next thing we're going to talk about. But for us to do division of mixed numbers, what we will do first is convert the mixed number into what we call an improper fraction, and then do what we did before. So converting this over, we got 13 over 9 divided by, what is this one converted over? 2 times 4 is 8. Add 1, 9, over 4. So this is 9/4. Pardon?
You skipped number 5?
I did. I skipped 5. Yeah, sorry about that. I put 6 here, but 5 looked a little too trivial to me. Yeah, I won't necessarily go through every problem because of time. Now we play that same game, right? We go through cross now. Oh no, be careful, right? You got to flip first. So you're going to do 13 over 9 times 4 over 9. And now what? Now multiply across, unless we can reduce. But I don't think we can reduce. So what are we going to be at here? 4 times 13. 52 over 81. That's it. Box it up. Move on. Okay, so that's multiplying and dividing fractions in a nutshell. Addition and subtraction is actually more difficult than multiplying and dividing. So if you think back to like when you were first learning numbers, way back when, they taught you to add and subtract first, and then they taught you to multiply and divide. But when it comes to fractions, we actually do multiply and divide first, and then we do add and subtract because it's more complicated. So let's take a look at this first one in adding and subtracting fractions. We have, well, let me give you something else before I give you one. How about this? If I give you 3/8 plus 7/8, because it's addition, what is the main thing that we want when you add or subtract fractions? What do you need?
Common denominator.
Common denominator, the same denominator. That means you need this to be the same as this, which in this case it is. And if you're there, then it's straightforward. All you do is 3, whatever this symbol is, 3 plus 7, which would be 10, right? Divided by, and you do not add the 8s, right? You just keep it, and you get 10/8. And reduce, something goes into both of these. They're both even, so 2, 5 over 4, box it up, we're done. So the goal of adding fractions together is to have the same denominator. If we have that, it's straightforward. I hope that's straightforward. So with that in mind, let's do this 1/8 plus 2/5. We recognize this is an expression, not an equation. It's addition, so I have to have the same denominator. So now we get to that place where I'm wondering what it is that you know. Like, what is the technique that you use? Because again, we're going to have different ways of doing this. So since they don't have the same denominator, I need to come up with something. It's called a common denominator, right? And there's actually one that we call the least common denominator, which would be the smallest number that is a multiple of both. What? The smallest number that is a multiple of both. So if you were to sit there and list out all the multiples of 8, 16, 24, 32, and you list out all the multiples of 5, and you try and find the smallest number that appears on both lists. What is it? 40. 40. Now you could write out those lists, right? But I'm not going to. 40. So the goal now is to turn this into a 40 and turn this into a 40. So how can I turn 8 into 40? Multiply by 5? So if I'm going to multiply this 8 by 5, I'm not allowed to just do that on the bottom, right? I have to do the same thing on the top. Remember that? So I'm going to multiply. I'll just rewrite it. I'm going to take the 1/8 plus the 2/5